So yeah, I'm gonna make coffee and then talk about Bitswap at the same time-ish. Gonna be doing this coffee I got in Spokane last weekend, or last week. It's a Mexican and Kenyan blend. I need to be in the camera. And it's pretty good, but grind it up here with my grinder, and then I'm gonna make it in the coffee siphon. I need to go grab some water, so 1 second. Alright, so there went my chair. Bitswap, for those who don't know, is the part of IPFS that manages like sending data between peers. So when I want something, I tell Bitswap, hey, I want this thing, and then Bitswap goes and manages asking everybody in the network for that thing. It's similar to how BitTorrent does it, in that it will, broadcast the things it wants and ask other peers for it and hope it gets them. But it's different because in BitTorrent, the people you're talking to are only people who are also interested in the same file. In IPFS's case, you're talking to a lot of people who may or may not have little pieces of the file or may not even care at all. So you have to adapt the algorithms a little on that regard to get things to work right. So on the coffee front, this is a coffee siphon for anybody who hasn't ever seen one before. It's pretty cool. You put water in here, and then I'll put this with a filter in it in the top, and then I'll heat up water in the bottom. It boils, and yeah, you'll see that in a second. But to boil the water, I use a little butane burner doodad, and gotta put butane in it. That's probably good. And let me grab the water. And I mix about 2 cups of coffee, which isn't really enough, especially since I normally do this for both me and my roommate. But since he's not here right now, this will be plenty. And fill up 600 milliliters or so. And I don't know if you can see the cool part down here, but get a fire. And then I just put this guy in here and wait for that to boil. So while we wait for that to boil, let's talk about where Bitswap is today. So today Bitswap has an extremely naive algorithm. It basically says every time you want something, tell everybody you know that you want it. And then on the other end, if you have a block and somebody asks for it, just go ahead and give it to them. The advantage of this is makes it easier to develop. It's really easy for us to just sit around and say, okay, we can test things without having to worry about incentives and making sure that all of the, I've given you enough, you've given me enough, we have, good balance, we like each other. You don't have to worry about any of that, because that really gets in the way of working on all the other parts of the system, which, it's good for us right now. The other thing is that it's very, very fast for the simple case of one person having a file and another person wanting it, because you don't have to worry about waiting or doing the blocks or like choking peers and doing all the BitTorrent logic behind that. So it works right now. Works pretty, surprisingly well, honestly, for how simple of an approach it is. But we need to change that. We're starting to notice that there are lots of duplicate blocks being sent. If there are 3 people in the network who have something and I ask for it, they're probably all 3 going to send it to me, even though my best effort is to, as soon as I get one block, tell the others I don't want it. They've probably already started sending it to me at that point, which wastes a lot of bandwidth, and it's bad for the network. So we need to figure out, well, either how do we decide which blocks to send, or how do we decide which blocks to ask, or honestly, both. So deciding who to ask for what is a hard problem. It's been solved-ish in BitTorrent, but as I mentioned earlier, our use case is a little different from BitTorrent in that not everybody we are talking to is interested in the same stuff we are. So we use the DHT to find out who actually has the things first, and then from there we can say, okay, these are the set of peers who have the thing, and then we want these blocks. So we can do a couple different things. We can, maybe just ask each peer, like maybe ask one peer per block, and that could probably work for now, as long as the strategy of always send doesn't change. And so if we, for now decide, okay, if we find a provider for a block, ask just one, that would probably save us a lot of bandwidth in the short term, until the opposite side changes of, okay, well now if somebody asks me for a block, do I really want to send it to them? And once that changes, the whole game gets fun because, well, now I have to figure out, okay, how many people do I have to ask to guarantee that at least one of them is going to send me a block in a certain amount of time, and I'm not going to get too much duplicate data. And that's something that we want to have, maybe an agent set up for, maybe a smart agent that can tweak these values and adjust, for you. Probably at first it'll be manual, okay, here's all your input values, here's A, B, C, D, E. You can tweak them until you find a good value. But, more advanced code is going to just do that for you. And that's good, because as the network grows and files become more and less popular, and different aspects of geolocation versus network churn and where you are and your bandwidth versus their bandwidth, those factors are going to change like really rapidly, and changing them manually isn't going to be super feasible. So like the number of people you request each block from versus how many you send to is going to change. Also, I don't know if you can see this, but the water's starting to come up here. It's kind of like really cold in my apartment, so this is taking longer to boil than it probably should. I also pulled it directly out of the fridge instead of heating the water up, so that happens. So back to Bitswap. That's what we have now and kind of where we want to start going. The actual mechanisms are, it's not an actual like request. I don't send you a request and wait for you to send me things back, kind of like a traditional RPC. It's more of a, it's like a market, exactly how Juan puts it in the paper, is it's, I basically make it known that I want these things. I'm standing here with a sign saying, hey, this is what I want. And people can walk by, and if they have the blocks, they can say, oh, here's this block. And it's completely, choice-based, as opposed to, me directly targeting you and waiting for you to return that, which I think is actually pretty cool as far as protocols go, because that whole, register your interest is more like a pub sub almost. Now Bitswap's kind of like a pub sub. I don't see Juan disagreeing, so I'm gonna go with that. So yeah, it's kind of cool. David, do you have any specific questions you want to ask me here?
So just to be on record, for example, do we have any specific strategies when we are searching for a block, looking for a block, but all of our peers that we contacted don't have that block? And actually the block that we are looking is a folder, is a UnixFS folder. So it has like a bunch of links. And I already know which blocks, like I know a list of blocks that I will want to fetch from that. Will I try to do DHT queries for each of those blocks that are listed on this Merkle-like node for this folder? Or will I do it just for one?
So, good question. We have an optimization right now where when I try to read like a folder or a file that has subblocks, we do a Bitswap request for multiple blocks at the same time, and then we initially just look for the person who has the root of whatever our request is, and then so we do one search for that, and then after that search is done, we send that person all of our want list. And that works out pretty well in most cases because, say we're requesting a file, I'll turn this down. Say we're requesting a file. Generally, if somebody has the top metadata block of a file, they're also going to have the rest of the file, which saves us a lot of time. And then Bitswap will also, if it doesn't get what it needs within a certain timeout, it will stop and it will go actually request each individual one again. So it has a fallback, but it tries the optimized path first. So now, as you can see, the water's in the top chamber. There's not much in the bottom. I turned the heat down low, pretty low, and now the fun part. Those smell good. Coffee in the top here, and mix it just a little bit. You don't want to stir it vigorously at first because you want it to what's known as a bloom, where the coffee beans get heated up and they release all the carbon dioxide in there. And the carbon dioxide's like a lot of the kind of bitter type flavors, so you want that to sit on top and just leave. Because if you stir it, that's going to get inside the coffee and it's going to add a little extra bitter flavor. So I stir this, now wait for about a minute and 10 seconds, give or take a few seconds. And so while this is going, the water is still boiling in the bottom, and every once in a while I get a little air bubble that gets pushed up through here. But for the most part, water stays up here, air stays in the bottom. Kind of weird, but yeah, that's physics. So yeah, I'm going to wait to talk about Bitswap more until I get this done because I'm watching a timer. And probably can't see this, but it's like bubbling a little bit on top here, and all the beans are just kind of sitting there getting good and soaked. And all right, cool. We're at time. So I will, pretty quickly, I'm going to cut the heat, and then I'm going to stir here. Pretty good now, stirring. And tilt this down. It's going to start sucking coffee back down. And this is like my favorite part because it's the only reason the coffee is coming back down is because the air in here is cooling and pulling the coffee through the really tight filter in here. And so the part that confuses me is this foam. The foam's because there's somehow air in the tube in the middle, but I don't know how there's air in the tube in the middle because there's just water above it. And that doesn't make too much sense to me, but whatever. And then, so this pulls down, and you'll know it's done when it starts like bubbling good. It's probably about 5 seconds here. I don't know how good my camera is or not. Oh, there we go. There's the bubbles. So it's done. And so now I can take this guy off. And pour myself a cup of coffee. So this is like what I'm doing when I'm talking on IRC, but not actually like conscious yet. This is generally where I'm at. But yeah, so that's coffee and Bitswap. Any questions?
Nice. Is the coffee good?
It's still pretty hot. Smells good though.
That's good. I have another question about Bitswap though.
That's pretty good. Okay, go on.
Specifically, if I looked at the API, specifically Bitswap stat, and most of them make sense after listening to your explanations.
Yep.
There's only the first one which says provides buffer. At the moment it says 0 out of 256.
Okay,
What
so
exactly is that?
the provides buffer is, so Bitswap has kind of two operations, right? You can ask for blocks and then you're sending blocks. So we've kind of, the provides buffer is an interesting thing because it doesn't quite belong there. It's when we add a new block, we add it through Bitswap. So we tell Bitswap to add the block. And what it does is it will grab the key of that block, and then it will write the block to disk, through your data store. And then with the key, it's going to do a DHT provides to the network. And that buffer is when we're adding tons of blocks, we can add a block much faster than we can actually provide it to the network. So that buffer is us just buffering up blocks to be provided. And it's kind of misleading right now because what we do is for every block, we spawn off a worker thread to consume that and provide it. So if you ever see that actually like filling up, something's really going slow or something, because it almost should never buffer there. That's going to be reworked pretty soon because it actually, surprisingly, buffering up a whole bunch of stuff takes up RAM. And got to take a look at that because that's partially responsible. That area of code is responsible for some of the memory issues David's seeing. But yeah, so that's what that does. Is that's basically us adding blocks and it's buffering up the provides. The reason for that, us adding blocks through Bitswap, is so that we can make kind of like a single interface for blocks. So you can say get a block and put a block, right? And you can also check if you have a block. And that interface is just done through, what's called the block service, which is a wrapper around Bitswap. So we can have this nice interface that feels like it's local. We can also have the same interface for just local blocks, but if you ask for a block, it's going to get it, whether it's on your disk or whether it's on somebody else's disk. And it makes it really cool because, it just feels like you have everything right there, no matter what it is.
Yeah. Then another question about the API.
Yeah.
There is Bitswap unwant and there is want list.
Mm-hmm.
Why is there no want command?
Okay, so I thought about adding a want command, and it probably should, just for the API to feel complete. But Bitswap want is just IPFS block get or IPFS cat a given hash. It does basically the same thing minus the spitting the data out. So, yeah, we probably should add a want command. That'd be pretty simple. You agree, Juan? Maybe? Yeah. Cool. Not even going to try the mic.
Not even going to try it.
I got half of that. If you want to repeat it, I can.
Oh,
yeah,
so
he has a mic.
having a Bitswap want command. So we have unwant to remove something from your want list, but having a Bitswap command to just add something to your want list without trying to read it. Yeah. Cool. So yeah, we can do that. Makes good sense. Any others? No? David, you look confused, actually. Or at least very thoughtful.
I was just thinking if I should bring as a question if there is any discussion of next features for Bitswap when it comes from well, tit for tat, Bitswap that uses other block stores, so just being the true IPFS, but use an external file storage somewhere. If there is any discussion right now, and since this is a video that other people can see, where are those discussions so that other people can join that thread?
Sure. We can talk about that right now.
Go for it. So
there's a few future things with Bitswap, different categories of things. But the one you mentioned is a different essentially transport for Bitswap. So right now Bitswap uses IPFS, to get blocks essentially. But you could also theorize a Bitswap that just used HTTP. For every time it wanted to go fetch a block, it would just query some HTTP endpoint for the block. and if it gets it, it gets it. If not, well, we failed. And that's a pretty cool abstraction to be able to make. Is there anything you want to say about that one?
Mike.
No, that's pretty good. You covered it.
Cool. All right, so the next part is how we request things. So right now, we request, I want this block. In the future, we want to be able to say, I want this block and everything under it. Or I want this block and everything under this part of it. And be able to specify Unix path-like requests for data. So you know how you can do like ls or regex, and it returns just the things that match that regex. Similar concept for Bitswap hashes, but maybe a little bit more power to it, so we can maybe specify every other or every third in a way that will allow us to be smarter about requesting. So the problem earlier of asking everybody for the same block and getting 10 of the same block, well, if we had a way to request every other block, that becomes a lot easier to mitigate the duplicate blocks you're receiving. And so it's going to be fun and a little tricky to write just because of the way IPFS itself works. Not necessarily Bitswap, but with IPFS it becomes tricky because hashes are put around a Kademlia XOR table, so things might not necessarily be close. So asking one person for all of these hashes, even though they're not likely to have them, it's a little weird, but we're already making assumptions that are similar to that anyways with the request just one person for all of these in the tree. So it's probably a good thing to make. Anything there, Juan?
Yeah, I can explain a bit about that language. So the goal is to construct a language that we're loosely defining DAG path notation, and the point of it is to allow you to express a subselection of a graph, right? So all of the references in Bitswap are so far hashes which point to a Merkle DAG, and so the point is to be able to not only express that one hash as that one node, but also subselections of the graphs they point to. So think of it kind of like CSS selectors or JSON path or XML, XPath, I guess, is the language, and be able to define queries that can express what you want and potentially in what order. And even beyond what order, you might want to do things like, say, I want to subselect this certain path, and I want you to prioritize some order, like send me, if you order all of the nodes in this graph, send me every other node, or maybe send me every mod 5 of the nodes in the graph, which allows you to express the same selector to multiple peers, and then ask for different subselections of the graph, which makes them send you different types of nodes to you, send you basically a set of interleaved nodes, and that becomes a really powerful and expressive replication model, because you can simultaneously give out these queries with these different constraints, and you can minimize any kind of duplicate nodes that you get, and at the same time avoid having to do round trips for selecting other nodes to get.
Yeah,
I can give an example of what this path might look like. I'm pulling up a slide. I have a stuff in slides.
Screen share? Oh, right, because you make thousands of slides every week.
Millions.
Dude, that one you gave for the QConf is 400 slides long or something.
Yeah.
I was pretty impressed with that.
Yeah, that one actually turned out pretty well. I have a lot of good stuff in that one. See, I will share my screen. Cool. So in this one example, so this is not what the language would look like, but suppose these are the kinds of things that we would want to be able to do, right? So in the first line, there's here $ref would be replaced by a specific hash or something, or you might even consider having variables. /* would say like, hey, get everything underneath this one hash. /** would be kind of like in Unix, get everything underneath it. But then you could start doing, you could select specific nodes underneath the graph, even if you don't know the hashes. And in that case, on the third case where you say ref/parent/parent/transaction/10, in that case, the other node is meant to send you ref, then ref parent, then ref parent parent, then ref parent 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 transaction, and then the last one with the 10. And that way you can verify every node along the way to get the last one. And there might be different ways of expressing like whether you want the whole path or you only want the last node. In the fourth example, there I have the idea of being able to express it kind of like a, as Jeromy was saying, a regex where you can, that one with a chunk /0. The idea there is that you can imagine a graph where files have a format where they have like a key called chunks, which goes into an array where 0 is the first element of the array, and then that goes into like another file. And so what this would do is it would say like crawl a graph, and at any time you see crawl the graph under movie.mp4. Every time you see chunks, take that link every time, and then go into the first element of that array and recurse, and do that as many times as possible. And then when you terminate, when you find like the last node, touch every single child of that node. What this gives you is a way of expressing, here's a graph that represents something like a movie, and what I want to get is the first few chunks going through the left-leaning side of the graph. So I can get the first few chunks of data that represent the movie and immediately start streaming those. That's how you might get like really fast streaming over a graph. But this could be any kind of graph, right? Like there, you're no longer tied to the layout of the graph. You can specify a query that optimizes this kind of behavior. The last one is where you might consider like embedding expressions within another one, right? So you could select, you could first do a selection on one like graph and pull out a value from that graph, and then use that value for another query. And so if the other node has ref1, ref2, then it can resolve this query entirely and return to you all of the nodes that you need to verify it for yourself, and do so in one, like without having to do these RTTs. Like what we're trying to avoid here at the end of the day is these huge gaps where, like if I were to request every single one of these nodes iteratively, I would first have to say, hey, give me a ref1. Once I get ref1, I figure out the hash for the next one, and then I say, hey, give me the next one, and so on. And that turns out to be really, really slow. And so if you can express this in a way that the other node can send me the whole thing, then that's much better. The other place where these expressions become useful is you can use them as conditions in programs, or you can start embedding these selectors all over the place and use them to represent pieces of graphs that might need to mutate or that might need to be sent or included in a bundle, right? So you can imagine saying, hey, I want to cache a sub-selection of the graph because I'm going to go offline and I want to cache like some selection of a graph for like offline reading or whatever. And you can select what that selection looks like with a notation like this. Cool. So anyway, not clear yet what the actual language will look like, but these are the sort of things that we want out of it.
Yeah, I really like, so like just looking at this and listening to you talk about it, it makes me think that we can generalize this just to not be like just for Bitswap. We can make this just be the IPFS path format itself, and take the path package that we have and put all of this logic there. So that way we have just one really cool way of defining queries over Merkle DAGs, which is really what we're doing here.
Yep. So this could go with the IPLD spec. It could be like a companion spec to it.
That would be pretty cool. Also, you were talking about like index selection. I think it'd be really cool. We can avoid like index selection pretty much completely when we move to forcing named links. and then like all of our files, all the chunks are just numbers. So that way you can actually, the name of the link is literally just the block index. And that way, yeah, we don't have to worry about any special logic for selecting an index. And then we just need to figure out the, meta escape characters to do reject file things.
Yep.
So that's going to be cool. I'm excited.
Yep. That'll be very, very interesting. Cool. Do we want to talk more about this one, or do we want other features?
I'm trying to think of what other features I was going to talk about.
I'm pretty excited about like hooks for other strategies and like being able to express agents that download other things. And this is many things. Like I think, Jeromy, you might want to talk about like different kind of bots that you might write. One of the things that I find interesting about this is being able to hook into different kinds of exchanges where, like today, like tit for tat and those kinds of data exchanges are like one-to-one, where you try and keep like an equal ratio of profitable data exchanging. But you could see this becoming asymmetric, where like you start taking into account the value of the data itself and say, actually, like this data is not that useful or valuable, so I'm going to discount it for some, like I'm going to multiply it by some constant that I assign to like the value of this data, and you can negotiate that before you start the exchanges. And then the extension to that is saying, like, attach cryptocurrency to it and say, allow nodes that speak a common currency format to be able to negotiate and move around data based on pricing. So you could turn around entirely how CDNs are done today by hooking up protocols like these, because you can create other kinds of behaviors like collect on delivery through cryptocurrency. And if you make it agnostic to the kind of cryptocurrency and create a protocol that allows any two IPFS nodes to negotiate the protocol and say, hey, like, do you use Bitcoin, or do you use Ethereum, or do you use like some other set of protocols, then great, like, let's use that. Exactly. So that's going to be pretty powerful for a lot of new ways of moving around data and content in the web.
Yeah. So it's really interesting that you bring up the value of data. So like, the value of a block. If a block's valuable, it makes sense that everybody's going to try and have it. But as soon as everybody has it, it's no longer valuable because the cost to get it is trivial. And so, determining the cost of a given, or the value of a given block is really, really interesting. It's like the inverse of the number of people who have it, and also the time between creation and, retrieval. That's going to be some really fun code to write.
Yep. And there's also things like, how quickly you can send it to me,
Right.
like bandwidth taking into account, right? So I might be willing to give you a higher share of credits, I guess, if you can get the content to me faster than everybody else. So that's where we can unlock a whole bunch of research that has been dormant in this area for a long time. So after BitTorrent came out, tons of papers came out trying to analyze different kinds of market-based data sharing systems. Many proposed cryptocurrencies or other kinds of credit accounting and so on. And some were like actually took it into trying to create like free markets of like creating valuations around data based on like how available it is, how many people want it, and like demand and so on. And this sort of thing, if you create like one protocol that you can hook into, you can have all these other things hook into, then it becomes really easy to play around with that kind of stuff. Because when those papers came out, they didn't really move the needle very much, because BitTorrent was a very closed, though it was an open source protocol, it was a very closed and locked down ecosystem where it was actually pretty difficult to change how the protocol moved data around. You basically had to be one of the leaders of, like, you had to have a very successful torrent client that everybody used, or a large percentage of the users use, to be able to introduce a new protocol into the ecosystem, because otherwise nobody would be using your one random extension that like nobody implements. So that will be interesting, and like being able to express some of these behaviors as scripts and be able to audit and sign these scripts to then have them be able to run on some subset of nodes that want to do this, where you might say, hey, like, I might be willing to engage in a protocol as long as it's signed by a certain set of people. And like, you may not even have to have the code beforehand. You can then get the code and then engage in that strategy.
Yeah, that's really the idea of like live updating code. You know, as long as it's okay. If this person sends me code, I'm gonna run it, and then being able to do a couple different things like recover from failures if they ship you code that doesn't work for you. Being able to not break and just revert to the old stuff. It reminds me of some paper I was reading about IBM's, I think it was IBM's mainframe stuff. Their compilers will put a bunch of extra space in your binaries. And the reason for this is if you update a function in your code, you can live patch that function into the running binary. And that extra space is used to perform those hooks. And so there's like locks around the code and extra things that it checks. And it was surprisingly performant and like really cool because you could have one application that runs for years and gets updated every week. And uptime, man.
Yeah. If you want to look at that, look at Erlang VM, which does that on a VM level. You can, so all Erlang systems can be patched live because the way it was designed is downtime wasn't allowed because otherwise nobody would have a telephone. And it was kind of uncool. So it's pretty amazing if you just inject your code and just, all right, let's upgrade.
Yep.
And you can just do live upgrades.
Yeah, that'll be actually. I'm a little disappointed with like operating systems of today because they mostly disencourage people from having lots of different processes to do small things. Because one thing Juan and I have talked about is like doing core IPFS functionality in separate binaries and just like using inter-process communication to do that, which would allow you to drop one of those binaries and start running the new one without the whole system going down at all. But those types of things are like still a little expensive and not as performant as something we would want just because of the way like OS process models work and memory management and shared memory. It's ugly. But yeah, things like that are really neat, and I think it'd be like, this is completely off topic from Bitswap, but this is like something I think would be really cool if we could figure out for IPFS. It's just, you just run the daemon and leave it running for the rest of your life. It's cool. Never worry about actually, restarting it. But
probably depends on how you in which language the daemon is implemented then, or you have to do a bunch of things probably on top of it.
Yeah, exactly. Be cool though. There was one other thing on the topic of Bitswap is so once you get to the point where it's a generalized request and sending mechanism, you can start scripting and you can start making AIs that just sit on the network and do data trading. They can listen in for what's in high demand and then get that themselves and rehost it, and then you get it becomes this place where you can start writing bots just to try and maximize their value to the network. And I think when we get to that point, it's going to be really fun because I've seen other bot communities before, like programmer fight type things where you like script a robot and they fight in some virtual arena. Things like that are actually beneficial to everybody. If we can get some sort of competition or challenges set up to build a better Bitswap AI, I think it's going to be really cool things happening,
How do you see the interaction? Do you imagine like a scripting language specifically for this, or API hooks, or because especially when you want to ship that like around, it kind of has to be predefined how this will look.
So there's a couple ways you can do it. Like obviously you can just make it easy for them to modify the source code and rebuild. You can also like ship some scripting language that Go will execute, the daemon will execute. Lua is really good for this, as is, I think, JavaScript with like there's certain JavaScript engines that run in Go, which would be pretty cool. And JavaScript's also more known than Lua, unfortunately. But yeah, so I think embedding a scripting language would be really cool, although it should be a separate build. But that's another topic. But it'd be really cool to do that.
All this kind of stuff could be in a separate special binary that has support for this kind of stuff, or even just like an extension that you can turn on. Yeah, and like on the scripting engines, like I think JavaScript, Lua, like WebAssembly will be interesting. There's a lot of AI work on Lua, so many games use Lua to write their AI bots. So
that's exactly.
There's probably a ton of like different libraries there that'll be useful.
Yeah, that'd be cool. So if anybody else has anything, now's the time because I'm out of Bitswap things to talk about. And David?
I was just going to say, I think like if we have other topics, like we can definitely have more of these sessions. I think we are in like a good size right now that other people can like watch it. Like if we can like talk for hours. We know ourselves.
Yeah, we're good. it probably would be good to like limit these to like 30 minutes or so.
Yeah, just I think it's very efficient. But yeah, I think that this is really good, and like we can definitely do for like all the other parts of IPFS. And also like after posting this one to IRC, we can see if other people are interested in being the ones like bringing questions, like specific questions about that specific part of IPFS. So that we, after the presentation of that component, we get like a very like what's the pain points of the community when they're trying to understand the part of IPFS.
Just a sec, David. Let's do Jeromy. You do a sign off, and then I can stop the broadcast, and then we can talk a little bit about how we can do that.
Yeah.
Before last sign off, I had one question on Bitswap, which I guess it's just like improving perf. I think like one of the things that will help IPFS perf a lot will be getting the DAG path notation that we explained before and a few other like improvements to Bitswap. So that's worth noting for people out there that more work on Bitswap stuff will be really useful to make IPFS much faster.
It's and optimized part of IPFS.
Yeah. And it has a lot of room to grow and get better. And in particular, like one of the pretty interesting branches of work is building simulators for understanding how Bitswap is doing things and how well it's working, and yeah, modeling that behavior there. So both Karthik and Ion have been looking into that to some degree, and that'll be probably like that would be an interesting chat to have on its own, just like simulating and modeling the network.
Yep, that'd be really cool.
Since we are doing like we are breaking Go with peer-to-peer into its own repo, we could do the same thing for Bitswap, and then like we can open this thread for
going to be broken into its own repo.
What?
Bitswap is definitely going to be broken into its own repo.
Yeah. So like the sooner we get that, like more people can come and just like focus on getting the AI really good, or like the simulation tools or the visualization tools, and yeah, let's open I know that like we have a lot of these discussions. On like the present notes. Let's try like I don't know, even if it's just like creating the repo, even if we don't move it entirely right now, but just like opening the issues with the pointers to all the other discussions and saying what we want to do, and other people will appear.
It'd be good if we just ripped it out in Dev Fora. But yeah, anyway, Jeromy, you sign off.
Cool. So yep, that was talking about Bitswap and making some coffee. So thanks for joining, and see you next week.
Thank you.